Hello everyone, welcome back to funedu. Today we will be going to discuss few important questions from KSET 2018 chemistry part. So let's begin with the first question. A quantity of PCl5 was heated in a 10 liter vessel at 250 degrees Celsius. It dissociates as PCl5 in equilibrium with PCl3 plus Cl2, all are in gaseous state. At equilibrium, the vessel contains 0.1 mole of PCl5, zero point 0.2 moles of PCl3 and zero point 0.2 moles of Cl2. The equilibrium constant of the reaction is. So, in the reaction, you need to find out the equilibrium constant. So, let me write the reaction as PCl5 gas in equilibrium with PCl3 gas plus Cl2 gas, and it is given the volume or the equilibrium moles of the reactants and products that are present is given. So that is nothing but PCl5 is 0.1 mole, PCl3 is 0.2 moles and chlorine is 0.2 moles. That is, the product is 0.2 moles each and the reactant is 0.1 moles. Now, we know that the equilibrium constant K is given as concentration of products divided by concentration of the reactants, correct? So, it means the equilibrium concentration or the equilibrium constant is the ratio of concentration of products divided by concentration of the reactants that are present in the given particular reaction. So if you see the given reaction, here you are having two products where you are having only one reactant. So the concentration of product is nothing but concentration of PCl3 into concentration of Cl2 divided by concentration of reactant is nothing but concentration of PCl5. So this is the equation that you can write for the equilibrium constant. Now you have to substitute the values of concentration of each terms that are involved in the equation. Now what is the concentration of PCl3, Cl2 and PCl5? Concentration is not given, correct? But the moles of the substances that are involved in the reaction is given. So we know the relation, right? Concentration, which is nothing but molarity if I consider. So concentration, any concentration or molarity, that will be equal to number of moles of that substance present in volume of a solution, right? So what is the volume? Sorry, number of moles per volume. So molarity is nothing but number of moles per volume. So if I substitute that particular thing for concentration here, what we will get? So PCl3, in case of PCl3, it will be equal to moles, that is 0.2 mole divided by volume, that is 10. So this will give you the concentration of PCl3. Similarly for chlorine, it is 0.2 by 10. So this is concentration for chlorine. Similarly for reactant, it will be equal to 0.1 by 10. So this is for the reactant. So then just solve the equation. So you will get K is equal to 2 into 0.2, that is 0.4 divided by 10, which is equal to 0.04. So this is our required answer, 0.04. So the equilibrium constant value is 0.04. So you can find the answer as C. So C is the correct answer, that is 0.04. So the second question, it says the standard reduction potential, that is E0 reduction, values of A, B and C are 0.68 volt, minus 2.54 volt, minus 0.50 volt respectively. The order of the reducing power is. So you need to find out the order of the reducing power. Here the order is given in the decreasing order, as you can see here. So you have to find the order in the decreasing order. Okay. So reducing power in decreasing order you need to find out. So here one thing you need to remember is higher the negative standard reduction potential, higher the negative standard reduction potential, greater will be its reducing power. Reducing power. So what do you mean by this? It means the reduction potential value and the reducing power, they are not directly proportional. It means higher the negative value, higher will be the reducing power. So if you see here, this is A, this is B and this is C. So out of the three, B is having higher negative magnitude, correct? So minus 2.54, higher negative value, that is for B. So since B is having higher negative standard reduction potential, it is having higher reducing power. Then comes C, which is having the second negative standard reduction potential value, that is minus 0.50 volt, and at the last you are having the positive reduction potential value of A, that is 0.68 volt. So the actual order will be B, having higher reduction potential or higher reducing power than C than A. So this is your required order. So where you can find this one? Here, D. So D is the correct answer. B is greater than C, greater than A. Then third one, half-life of a reaction is found to be inversely proportional to cube of its initial concentration. The order of reaction is. So here you need to find out order of the reaction. So what is given? The statement says that T half is inversely proportional to cube of its concentration. So if I consider small a as the concentration, then T half is inversely proportional to 1 by A cube. Correct? Yes. But we also know that T half is directly proportional to A to the power 1 minus n. So this is the known equation. You have to remember this equation. T half is directly proportional to A to the power 1 minus n. So by comparing the two equations, we can write A to the power 1 minus n is equal to 1 by A cube. Correct? On comparing these two equations, I can write A to the power 1 minus n is equal to 1 by A cube, or A to the power 1 minus n will be equal to A to the power minus 3. Just to bring this A cube from denominator into the numerator. So we will get A to the power 1 minus n is equal to A to the power minus 3, or I can also simplify this as 1 minus n is equal to minus 3, or minus n is equal to minus 3 minus 1, which is equal to minus 4, or n is equal to 4, because minus n is equal to minus 4, so I can cancel the minus minus. So we will get n is equal to 4. So what is the order of reaction? The order of reaction is 4. So D is the correct answer. Next, the relation between delta E and delta H. Okay, the relation between delta E and delta H is. So you need to find out the relation between delta E and delta H. Now in thermodynamics we have already studied. What is that? The relation between enthalpy and the internal energy. What is that relation? H is equal to U plus PV. Correct? For any given system, the enthalpy and internal energy relation will be equal to H is equal to U plus PV. Now, suppose if you have two systems, then for the two system, I can write it as H1 is equal to U1 plus P into V1, considering pressure as a constant term, and H2 will be equal to U2 plus P into V2. This is equation 1, this is equation 2 for two different systems or for two different states. So H1 will be equal to U1 plus P into V1, H2 is equal to U2 plus P into V2. Then equation 2 minus equation 1 will give you H2 minus H1 is equal to U2 minus U1 plus P is a constant term, so it will remain outside, into V2 minus V1. Correct? So this is what we will get. H2 minus H1 is equal to U2 minus U1 plus P into V2 minus V1. Now what are these? H2 minus H1, U2 minus U1 or V2 minus V1? They represents the change. This represents change in enthalpy. This represents change in internal energy. And this represents change in volume. Correct? So this is change in enthalpy. This is change in internal energy. I will write it as energy, and this represents change in volume. Change in volume. So we know that this change can be written as delta, right? So the change usually is represented in terms of delta. So this is nothing but delta H. So delta H is equal to delta U plus P into delta V. Or we also know that internal energy can be represented in terms of U or E. So delta U will be equal to delta E. So I can write it as delta H is equal to delta E plus P into delta V. Or so this is our required equation. So just compare with the all options given. So the right answer is A. Delta H is equal to delta E plus P into delta V. This is the correct answer. Yes. Next one. Using the fundamental equation dA is equal to minus S into dt minus P into dV, the Maxwell relation is. So we need to find out the Maxwell relation in this case. Now, Maxwell relation for this particular can be calculated or identified by using Maxwell's relation itself, or even you can use Euler's theorem. Okay. So what is this A? A represents Helmholtz equation, correct? So Helmholtz constant or Helmholtz equation, right? A represents. Now this Helmholtz constant, this is A, this is equation for Helmholtz constant. Now this can be solved by using Euler's theorem. Now what is Euler's theorem? Euler's theorem. So let us solve this by using Euler's theorem. Now by using Euler's theorem, we can write Euler's theorem says dz is equal to m into dx plus n into dy. Okay. So now this is Euler's theorem. What Euler's theorem says, dz is equal to m into dx plus n into dy. And from this we can write, see, delta m by delta y at constant x is equal to delta n by delta x at constant y. Okay. How we have written this particular equation? So just cross differentiation. Okay. So differentiation of m with respect to y and differentiation of n with respect to x. Since here you are differentiating m with respect to y, x will remain as a constant. So delta m by delta y will be at constant x, that is equal to delta n. So n is with respect to x. So delta n by delta x at constant y. Okay, y will remain as a constant parameter. So similarly, if you compare the same thing with the given equation, what is given equation? That is dA is equal to minus S into dt minus P into dV. Okay. So this is given equation. If you compare the same thing with the given equation, what I can write? S will be differentiated with respect to dV and P will be differentiated with respect to dt. So I can write delta S by delta V at constant temperature is equal to delta P by delta T at constant volume. Correct? And don't worry about the signs that are present, positive and minus, that is not going to affect here. So what is the relation? Delta S by delta V at constant temperature is equal to delta P by delta T at constant volume. So just to find out, so T and V are present here and here. So the correct one is this one, D. So delta S by delta V at constant temperature is equal to delta P by delta T at constant volume. So that is the Maxwell's relation for the given equation. Yes. Next question. At the triple point of water, the number of phases in equilibrium is or are. So this is simple. You have already studied the phase diagram of water, correct? So in phase diagram of water, you can see pressure against temperature, correct? Yes. So if you draw the phase diagram of water, then in that we can clearly see that at the triple point, this is called triple point, triple point. So at the triple point, we are having equilibrium between solid, liquid and gases. So at the triple point, you can see the equilibrium between solid, liquid and gases, correct? So there is an equilibrium between all the three states. So since there is an equilibrium between three states, at a triple point, the total number of phases in equilibrium are 3. Okay. So this is very simple. This is conceptual. Yes. So the next question says, the value of 1.380649 into 10 to the power minus 23 joule per Kelvin represents. So this particular value of a constant represents which constant you need to identify. So you are having the option Boltzmann constant, Avogadro constant, Planck's constant and gas constant, and you need to identify the correct one. So Avogadro constant you have already studied, right? What is that? 6.023 into 10 to the power 23 per mole. Particles per mole, atoms per mole, molecules per mole, that depends, right? So per mole we are defining it. So Avogadro number is 6.023 into 10 to the power 23. Correct? Yes. Similarly, if you see Planck's constant is 6.626 into 10 to the power minus 34 joule second. Correct? So this is Planck's constant. And similarly, if you see gas constant, it will be equal to 8.314 joule per Kelvin per mole. Joule per Kelvin per mole. Or you can also write it as 0.0821 atmospheric liter per Kelvin per mole, or that is also equal to 2 calorie per Kelvin per mole. 2 calorie per Kelvin per mole. So all the values are gas constant can be expressed in all these given values. Okay, so majorly we use this particular relation, that is gas constant is equal to 8.314 joule per Kelvin per mole. This particular value we will use in many of the cases. So if you see Boltzmann constant, what is Boltzmann constant? So we know that Boltzmann constant can be written as Kb is equal to the ratio of gas constant. So it is a ratio of gas constant to Avogadro number. Avogadro's number. Okay. So that is equal to R divided by Na. So if you substitute the values of gas constant and Avogadro number as So substitute the value of gas constant 8.314 joule per Kelvin per mole divided by Avogadro number 6.023 into 10 to the power 23 per mole. So per mole get cancels. Then on simplification we can get Kb, that is Boltzmann constant value as 1.38 into 10 to the power minus 23 joule per Kelvin. Okay. So now this is the value of what? Boltzmann constant. So by this calculation, we can conclude that the value given, that is 1.380649 into 10 to the power minus 23 joule per Kelvin, this represents Boltzmann constant, not any other constant, because we know the values of other constants. So it represents Boltzmann constant. Yes. So the next problem, it says delta square in the equation, that is delta square into xi plus 8 pi square m divided by h square into e minus v into xi is equal to 0 is known as. So what is this particular term in this equation is known as? That is what they are asking. So this one we have already studied. What is a Hamiltonian operator? So Hamiltonian operator is nothing but h cap, correct? So this h cap is equal to minus h cross square divided by 2 m, correct? So Hamiltonian operator is equal to minus h cross square by 2m into delta square plus v. Now this is nothing but your Hamiltonian operator. Similarly, if you see the angular momentum. So what is angular momentum? So angular momentum is L. L cap is equal to I cap into Lx plus J cap into Ly plus K cap into Lz. Okay. So this is what? This is angular momentum. And similarly, if you see the energy operator, so both energy operator and the Hamiltonian are same. Okay. So if you see energy operator, this is equal to E cap I will write. Okay. So both are same. Hamiltonian operator and energy operator, their equation is almost the same. That is minus h cross square by 2m into delta square plus v. Okay. So this is what? This is Hamiltonian and energy operator, and this is what? This is your angular momentum operator. Okay. So what is this del square then? Del square is nothing but your Laplacian operator. Okay. So this Laplacian operator is nothing but your del square. Okay. So del square is Laplacian operator, which is equal to del square divided by delta x square plus delta square by delta y square plus delta square by delta z square. So now this is your Laplacian operator. Delta square is equal to delta square by delta x square plus delta square by delta y square plus delta square by delta z square. So del square in the equation is known as Laplacian operator. So B is the correct answer. Next question. If the function f is equal to e to the power minus ax is acted upon by a operator d by dx, the eigenvalue and eigenfunctions are. So you have a function given as f is equal to e to the power minus ax. Now this is the given equation. So what you need to find out, it is operated by d by dx. Okay, this particular function is operated by this derivative, that is d by dx. You need to find out eigenvalue and eigenfunction after differentiating. Okay, so that is nothing but d by dx of e to the power minus ax you need to find out. Okay, so it is equal to what? D by dx of e to the power minus ax. If you know the differentiation, you can do it easily. So it is what? Minus a, that is constant. Which one is a constant here? Minus a, right? Because you are differentiating with respect to x. So minus a into e to the power minus ax, correct? So this is what? This is the differentiation of the given function. Now this is similar to what? This is similar to d by dx of xi equal to a constant, a differentiation constant k into xi, correct? Where you can see both are functions, correct? Both are the same functions. Similarly here also you can see in both sides you are having the function. So they are called as eigenfunction. Okay, so these are called eigenfunction. Eigenfunction. And the constant of differentiation whatever you are having, that is eigenvalue. Okay, this is eigenvalue similar to k. This is eigenvalue, this is eigenvalue, and this is eigenfunction. Okay, yes. So what is the answer? The eigenvalue will be minus a and eigenfunction will be e to the power minus ax. So minus a and e to the power minus ax you need to find out. So that's why a is the correct answer. In the a you can see minus a and e to the power minus ax as the eigenvalue and eigenfunction values. So a is the correct option. Next question. The quantum mechanical operator for kinetic energy of a particle moving in 3 dimension is. So you need to find out quantum mechanical operator for kinetic energy of the particle. Now what is this kinetic energy? This is nothing but T cap, right? So kinetic energy I can write Ke also. So kinetic energy I will write it as temperature T cap, that is equal to minus h cross square divided by 2m into delta square. So this is what? This is your kinetic energy. Similarly, for example, if you see this. Okay. So if you see here, this particular value, okay, so H cap is equal to Hamiltonian operator, whatever I have written here, minus H cross square by 2m into delta square plus V. So in this particular equation, you can see this is what? This is kinetic energy, and this term represents potential energy. Okay, so same thing you are having here. So the kinetic energy T cap, that is equal to minus H cross square divided by 2m into delta square. This represents the kinetic energy. Now I can, but we know what is this H cross square. So H cross is nothing but H by 2 pi. Okay, so H cross is nothing but H by 2 pi. So if I substitute that one, then I will get minus H square divided by 8 pi square m into delta square as the kinetic energy. So kinetic energy will be equal to minus H square divided by 8 pi square m into delta square. So you need to find out this particular answer. Okay. So where is that answer? Minus h square divided by 8 pi square m into delta square. So A is the correct answer. So here you are not having minus. So that is wrong. And here you are having reverse. That is similar to your Schrodinger equation. And here you are not having any particular values. So the correct answer is A. So that is minus h square divided by 8 pi square m into delta square. So either they will give you this particular answer, or they may give you this particular value for the kinetic energy. Okay, both are possible. So in this case, they are giving in terms of H cross, and here they have just applied the value of H cross. What is H cross? H cross is equal to H by 2 pi. On simplification, you will get this particular value for the kinetic energy. So that's all for today. So we'll continue in the part 2, the remaining questions of KSET 2018. Thank you.